All right, and so now this works with, even if we have to split up a wire into like a lot of little pieces. So we take, and we add up the whole path. The total force on the wire is still IL cross B, even as we're adding up all those little places where L is the straight line path from one to the other. Because if you're adding up all those little pieces, things that are at different angles will eventually cancel each other out. You think of it that way. And so even this wire that's in this next example, right, there the force on the wire is 0. Even though, one side's a little longer and then there's that curved part, all of that is eventually going to cancel out somehow when you add up all the components in the different directions. So the force on any loop, if the full loop is in the magnetic field and it's constant size and constant current, then the force is going to be 0. And then in example 6, let me draw this one. And so A says find the magnetic force on the straight section of the wire. Well, the straight section of the wire, the force F is IL cross B, but L here, this length is 2 times the radius, and I is this vector of the length is perpendicular to B, so this is just going to be 2 IRB. All right, and then what direction is this going to be if we're looking at this as a vector? Right. Well, current is this way, magnetic field is up, so this is into the board, so it's going to be negative 2 IRB in the K direction. And what about for the top half of the arc, right? That, when you add up all these pieces, right, there is some up component here, but then that gets canceled out by all the down components over here, and so here the current overall from here to here is that way. So IL, right, IL, L is ultimately that way, IL cross B, and this is coming out of the page, right? So F is 2 IRB, okay, and so then the total force, F net, on the whole thing is 0 newtons. These should all be newtons, by the way. And so then what about D? Well, the force here on this part is into the page, right? And the force on here is out of the page, so it's going to spin like this, where this part of it is going to be coming out of the page, and then this piece is going to be going into the page, and so it'll spin top forward. That'll end up being the resulting motion.